So the units come factory charged for 15 feet of line set. Okay, that's with 3/8 line. Has to be 3/8 across the board. Um, anything additional, okay, you're going to have to weigh in or use the subcooling method. Now, there's pros and cons to some of this stuff. So, we'll go ahead and cover this. Weighing in is my personal preference because of several reasons. One, it's very accurate, and two, it's very fast. Another thing too is I don't have to rely on favorable ambient conditions. There are certain conditions where I cannot charge by subcooling. Okay, and if I weigh in the charge, it doesn't really matter what condition is happening. I can weigh in the charge and I know it's right. Okay, so we're going to go through both methods though and tell you how to use them and show you. Okay, so weighing in, our favorite because it's fast, it's accurate, and it doesn't rely on outdoor conditions or indoor conditions. You can weigh in the charge no matter what's happening. And if you don't know anything else, you know the charge is right. Okay, now weighing in, go into your service hat icon there. You got to hold it down till it turns green, and then you get into the advanced menu. You go down to refrigerant charging, and you select weigh in. Okay, and it'll tell you you have to put in the line set size, the vapor line size. How many feet. Okay, and the diameter. And then once you make the adjustment, you save that and it'll ask you, are you doing a new install or a complete recharge? Most of the time it's going to be new install. Okay. The time you would select complete recharge would be like, I had to replace the compressor or something like that. Then you would do a complete recharge. But if you do new install, then it'll tell you exactly how much you need to weigh. Okay. So select new install, and hey, you know what? We told it how many feet and the vapor line size. And so now it comes in and tells you, okay, you got to add this much to the charge. Okay, so it does the math for you. Now you can go with the 0.6 ounces per foot of 3/8 liquid line. Now, that's across the board on Carrier Bryant equipment. But if you don't want to do the math, this will do it for you. Okay, so very intuitive there. And there's a charge breakdown if you want to know how much was added for the line set and how much for the indoor coil, etc. You can go to the charge breakdown, and it'll break it down for you. Okay, if you want to know that. Okay, now, yeah, complete recharge. Like I said, you would use this if you are replacing a compressor, made a repair in the outdoor unit, something like that. Then you would use the complete recharge. And again, it'll give you the breakdown. It'll tell you exactly how much to add for the condensing unit, the lines, and the evaporator coil. Or fan coil. Subcooling. Okay. I like pressure enthalpy charts. They tell you a lot. So that's what this is. Enthalpy is your BTUs down here at the bottom. On the left is pressure. Okay. And this is always done in PSIA, but we converted it to PSIG because that's what we're all used to. Okay. But in this bubble here, okay, and the bubble is like this, everything inside here is a saturated refrigerant. Okay, so liquid and vapor. Everything on the left side is 100% liquid, and everything on the right side is 100% vapor. Okay, so inside here is our saturation. Now, I guess, what do you call this? This is a chart of the vapor compression cycle. Okay, and I always start at this point here. This is the outlet of the metering device. Okay, so we meter the refrigerant, we put it into the evaporator, we have a mixture, right? It's boiling, it's absorbing heat from the air. And as it's doing it, it's slowly becoming more and more vapor. Okay. Once we get to the edge of the bubble, we are now 100% vapor. Okay. And I'll zoom in here a little bit. Okay. Notice at the edge of the bubble, we have a slight dip and we go down. Okay. This is normal. We have a pressure differential, typically, uh, equates to 2 degrees. Okay. And that's from the outlet of the evaporator to the compressor. There's got to be pressure differential for the gas to flow. So this is normal. Okay. Now, if I had a kinked suction line, this dip would actually go way down. Okay. Because your pressure would drop a lot. Okay. I have something on my lip. I blew my nose in the break. Maybe that was it. Maybe, I don't know. Somebody sent me a message, said I had something on my lip. I don't know. I was blowing my nose during the break, so maybe it was from the tissue. So thanks for pointing that out. Anyways, so if you had a kink in the suction line, this dip would go way down. And before it came back up. So what you see here on the screen is a normal operating system. Okay, as the vapor enters the compressor, we compress it and we add heat to it, and therefore it goes up. Okay, the pressure increases and it goes slightly to the right because the heat is increasing. Okay, and I'll zoom out here. So this is the exit point of the compressor. This little portion here is our discharge line, 100% vapor. And now we enter the condenser coil where we begin to reject heat. Okay, and we have a saturated mixture again. Okay, once we get to the exit of the condenser coil, we should have some subcooling develop. Okay, 100% subcooling means we have liquid that's developed. And then at this upper left corner is where we enter the metering device. We have a sudden drop in pressure and we enter the evaporator. We start the cycle over again. Okay, so that is the vapor compression cycle on a pressure enthalpy chart. But subcooling is this portion here. Okay, and subcooling, when you're charging a system by subcooling, there's favorable conditions. Okay, you cannot just charge by subcooling at any point. Now, most of the time, we're within these conditions. Sometimes we are not. Okay, so we have outside conditions between 65 and 100 degrees. If we're outside of those conditions, we can't use subcooling. Inside, between 70 and 80, if we are there, then we can use subcooling. If we're outside of that, then we cannot. Okay. Now, middle of the summer, you do a change out. Inside is probably going to be above 80 degrees. Outside, you'll be below 100. Okay, maybe 99, but you'll be below 100. So then, you would have to let the unit run for a while before you could begin to use subcooling as your charging method. Takes time, right? So that's why we advocate using the weigh-in. Now you can use subcooling though, it's perfectly fine. Same thing, go into the refrigerant charging in the user interface, click on subcool. Okay, it'll give you a value here, target subcool. This says 8.3 degrees. This is not what you use. Notice there's a start button down here. You have to hit start. Okay, this is just kind of a placeholder. All right. Yes, ensure the service valves are open before you press start. It seems kind of silly, but I've had those calls. A guy say, hey, the unit's not working right. We get to figuring out some stuff, and guess what? The liquid line service valve was still closed. Okay, well, you got to open that one, so keep that in mind, right? So then once you hit start, you get to this screen here. Okay, and it'll give you target service valve subcool, but there's also stabilization time. You have to let the stabilization time expire before you can use the target subcool value. Because, for example, on the screen here, it says 8.3, but after the timer expires, it may change it to 12. Okay. And so, if you go by the number that's on here, without waiting for the stabilization time to expire, then you could have a problem. Okay. Maybe under or overcharged. All right. So just keep that in mind. Again, use the subcooling if you want. If you like to do it, that's fine. I always prefer to weigh it in because it's fast. I would weigh in my charge, turn the unit on, let it run, clean up my stuff. By the time I'm done cleaning up, it's ran 15, 20 minutes. Then I can go check my subcooling, check my superheat, amp draw, that kind of stuff. All right. So, you guys develop your own method, but that works really well. Software updates, right? You got a VFD, you got a PCM. Once you turn the unit on, you can check software of this equipment. The software is not going away. The more and more energy efficient these units become, the more and more software will be ingrained in them. And it's something we're just going to have to live with, guys. We're going to have to get better at it. Okay, airflow, these are communicating systems, and the outdoor unit has a lot of, I guess, pull, you could say, with how much airflow the indoor unit provides. The previous Infinity and Evolution systems did not have as much, pull, I guess you could say, when determining the indoor airflow. Okay, but this particular outdoor unit has a lot of say in how much airflow the indoor unit provides. All right, and it's all done through communication. Now, the default airflow on the user interface is comfort. Okay, and that is, what we recommend. You can change it to efficiency and max. Okay, now if you go into efficiency, if you have the 5-ton, your unit will allow the vapor injection circuit to become active at certain times. Okay, extreme ambience generally. Now, max airflow, that's going to be more like, hey, I need 400 CFM per ton. I don't want to deviate from that. I need the max, and that's what you get. There's no dip switches, even the furnaces that are communicating, you might see a dip switch on the board, but they don't need to be adjusted when you have an Infinity communicating system. So updating, right, the software, getting it done. There's 4 different components that can receive software updates. The wall controller, we talked about that already. The PCM, that's a primary control module. The BTM, Bluetooth module, and the VFD, or inverter, if you will. Okay, all of these components can be updated with software. Now, when it's connected to Wi-Fi, okay, the user interface can get a software update, and it can update all of these components. All right. You can update all these components with a micro SD card. All right. If you're going to connect to the unit outside with your mobile device and use Bluetooth, you can only update the components in the outdoor unit. You cannot update the wall controller through Bluetooth. Okay. So just keep that in mind. When you connect, you will have a screen that's similar to what's here on the left. At the bottom, it says firmware. You click on the firmware, and it'll tell you what the current version of software is for the outdoor unit and the different components. And then it'll tell you if there's an update or not. There'll be a little notification, like a little number 1 or something that'll sit there, and you'll know, hey, there's an update available. Okay. Doing the update with the outdoor unit through the Bluetooth module is very fast, very effective. And, but again, you can only update the outdoor unit components. So, the best way to do it is through the Bluetooth Service Tech app. And we'll show you that here in a little while. But if you look You can look in your Apple iStore, your Google Play Store, search for Carrier Service Tech app or Bryant Service Tech app, and you'll find it. Okay, but we'll show you a little bit later too. Um, so here's different ways to update, the units. Here's some screens that you'll see. Here's, I was telling you, it has a little number 2. So that means there's 2 software updates for different components. And so, you'll see that once you connect, tells you at the top you're connected. You can only connect to 1 unit at a time. And it'll tell you the model and serial at the top. So, you got a high-end home with a couple of these units next to each other, you're going to know which one you're connected to when you're looking at the app. Okay, firmware update. Once you begin the process, your mobile device has to stay within 10 feet. If you walk away and your phone's in your pocket, it'll just abandon the update. It won't hurt anything, but you'll have to start it over. Okay, so it takes longer. Once you're done, it'll tell you update successful and you're good to go. Go on your way. Okay. There were some issues where the outdoor unit software was not compatible with the wall control software. You would get an alert on your phone when you connected. That happens if the outdoor unit software is outdated, but honestly, these units have been around for a couple of years now. I don't think I've ever taken a call where I had this issue. Okay, so just keep that in mind. You could see that with like an old user interface software, or old outdoor unit software. Okay. So in order to fix it, you just got to update it. That's pretty much it. Now, talked about it before, but connecting to the Wi-Fi network, you want to use the wall controller to connect to the homeowner's network. The homeowner is going to need to provide the network ID and password in order for you to connect. It's the same process like you connecting your phone to a new network for the first time. Okay. So you want to take some time to set this up for the homeowner. There's a lot of capability that is enabled when you have a Wi-Fi setup. And there's also a connected portal that we'll show you a little bit later. Here's kind of a sneak peek, but you can, as a dealer, remotely view the homeowner's unit. So, Mrs. Jones calls up and says, hey, unit's not working. Okay, well, I put the unit in for Mrs. Jones. I'm going to log in and I'm going to look and see what is the fault codes, what's happening. Okay, I can't make changes. I can't, turn up the heat or turn down the cooling, but I can view it. Okay, and so being connected through the portal will give you that ability to view. Real quick, I'll just jump over to our website. This is where we were earlier. Okay, I'll go back to the home page. All right, so this is where you're going to land on the home page. You're going to go to equipment documents, T-stats, controls, and zoning. Okay, and scroll down. This is where we had the software before. Keep scrolling down. We have some other products there. All right, a little bit further, and here's your Carrier and Bryant's connected portal. Okay, there's a connected portal setup guide. Okay, it's about 10 steps. And it makes connecting to the homeowner's network and setting it up very easy. Kind of a 1, 2, 3 step-by-step thing. Create your account, complete the registration, that sort of thing. So, this is what you need to set up if you want to remotely view somebody's system. Okay, and so that is a lot of value there. Mrs. Jones's house is an hour and a half away. I don't want to send a technician out there and find out, hey, he needs a fan motor. Go to the store, get the fan motor, come back. So that one call took you all day. If I can log in and say, hey, she's got fan motor faults, I'm gonna send the tech with a fan motor, right? And that way, hopefully, you can eliminate some travel there, right? So there's a lot of value. Okay. There's a question that came in. We have to set it up for each customer. I would recommend you set it up for each customer. Um, you don't have to, but you don't have that ability, so it's really not that difficult. And like I said, we have the setup guide. Yeah, once it's set, then you're done. You never have to change it again. And then at that point, you'll be able to log in to your connected portal and view the system if there's any need to. Okay, so what's in the box? All right. You got on the left here 2, 3, 4, and 5 ton. These units are only whole tonnages. You cannot get any half tons. Okay. Rotary compressors up to the 4 ton. The 5 ton has a scroll compressor. Obviously, each unit will have an inverter or VFD. There's a little bit of difference in how the inverters look, but the 2 and 3 is essentially the same, and then the 4 is different and the 5 is different. Okay. Each unit has a compact ECM condenser fan motor. It looks very similar to the fan motor that's on the 25 VNA 8 or the 24 VNA 9, but it is not the same, but it looks the same. Now on the 5 ton, you have a vapor injection EXV. Okay, if you have heat pumps, 25 series, or the 2 on the Bryant, then you'll have a heating EXV. You can see heating EXVs. If you have a 5 ton heat pump, you're going to have heating EXV with vapor injection. Okay. Each unit will have a Bluetooth module. The 5 ton has a scroll compressor with a vapor injection circuit. Okay, and we'll talk here a little bit about the vapor injection circuit and how it works. Okay. Here's your rotary compressor, twin rotary, DC inverter driven on the 2, 3, and 4 tons. The 5 ton is a scroll compressor with vapor injection. So the vapor injection is a third port on the compressor. All right. Now, this is not new technology. This technology has been around for a while. It's being incorporated here into the residential equipment because at extreme ambience, the density of the refrigerant changes. And we want to keep this unit as efficient as possible. So the vapor injection circuit is there for exactly that, efficiency reasons. Let's keep the compressor operating at maximum efficiency throughout all the different conditions that could possibly occur. Okay. So on top, you see standard operation. Suction is suction, discharge is discharge like normal. Okay. When vapor injection is active, we have gas, refrigerant, vapor flowing into the compressor at mid port. Okay. And we got some videos a little bit later to show you. This is kind of a cutaway, a look at the 5 ton with the vapor injection. There's a brazed plate heat exchanger. This is our vapor injection EXV. This is our heating EXV. Obviously, you can see a reversing valve. There's a muffler. We got a compressor. We got a couple transducers, discharge and suction transducer, and a pressure equalizing valve. Okay, so there's a lot going on in there. But it's not too bad once you take it all apart, put it back together. So here's our standard operation, right? Compressor, condenser coil. Here's our vapor injection, okay, with the brazed plate heat exchanger, and then our evaporator. Okay, so first we're going to look at standard operation, right? This is discharge vapor going to the condenser coil. We begin rejecting heat through the condenser coil, and we have a liquid. Now with standard operation, the liquid just passes through the brazed plate heat exchanger. That's it. It just goes through it and off it to the liquid line, to the metering device, and back to the compressor. Okay. So that's just standard operation. Now, when we have vapor injection active, we are going to then send a portion of this liquid to a metering device, which then feeds it into a heat exchanger, like a coil, okay, and then back to the compressor. All right, so here's standard operation. Vapor injection becomes active, and here we see now there's a portion of liquid. The animation stops when I draw on the screen. Portion of liquid comes through and feeds into the heat exchanger. So what happens is on one side of the heat exchanger, we have a mixture, right? Saturated refrigerant, and the liquid line is gaining additional subcooling. Because remember, this liquid just passes through here. It gains additional subcooling before it heads out the liquid line to the indoor metering device. Okay, so there's my animation. So that it helps to further subcool it. And then you put that refrigerant vapor back into the compressor at mid port. All right. And so that is, in a nutshell, the vapor injection of the unit. Now, again, vapor injection is there for efficiency, right? That's the main point of it. Heating EXV, you're going to find this on your heat pumps. Okay. Um, yes, someone pointed out that walk-ins have a heat, like a heat exchanger like that. Yeah, like a subcooler. That's exactly what it is. That's exactly what it is. So good pointing that out. And then a question, why does the 5-ton have the vapor injection and not the lower ton units? The 5-ton is larger. Like I said, it was more for efficiency reasons. The 5-ton uses more electricity, if you will. It costs more to operate because it's larger. So by using the vapor injection, they were able to bump up the efficiency and make it more efficient. Okay. So the heating EXV, though, it's used in conjunction with the PCM, primary control module. 475 steps from fully open to fully closed. And the coil resistance is actually published here and in the service manual between 43 and 49 ohms. At the start of each heating cycle, the EXV is going to drive to a fixed position for 2 minutes. All right. After that, it'll begin to start modulating and start controlling superheat. Okay. There is a suction line thermistor that works in conjunction with it. And so that's how it can determine superheat and then open and close the valve based on the needs. Now, in cooling operation, the heating EXV is 100% open, and defrost operation is cooling, so it's also 100% open. The vapor injection EXV is exactly that. It's for the vapor injection circuit only. Now, it looks just like the heating EXV, but they are not interchangeable. They are two different part numbers, and so you cannot, use one in place of the other. All right. And we said it a couple times. It's used to achieve higher capacities during high ambient cooling, low ambient heating in the efficiency mode. Remember, in the user interface, you have to select that efficiency mode. Now, by default, it comes set to comfort. Okay. Components and sensors, right? Primary control module. This is the brain of the unit. Okay. This does a lot. It looks at the VFD, the heating EXV, controls vapor injection, makes decisions based on inputs. Okay. There's all kinds of sensors in the unit: suction pressure transducer, discharge pressure transducer, outdoor air, outdoor coil, suction thermistor, high pressure switch, discharge thermistor, and then it's also looking at the VFD. So it's got a lot of inputs, and all this information that it's receiving, it can then make a decision. Hey, suction pressure is high, what's going to happen? Well, it could have damage to my compressor, right? So what I'm going to do, back off capacity, maybe even shut the system down, okay, that sort of thing. So, all these sensors are inputs. And then based on the input this board receives, it's going to make a decision that affects the unit. Outdoor air temperature. This thermistor is a 10K ohm thermistor. You've probably seen it on other Infinity and Evolution models. Nothing's really changed here. 10K ohm thermistor. If the sensor fails for whatever reason, the unit will continue to operate, but at a reduced capacity. There are some issues with defrost if this sensor fails, but it's going to be based on coil temperature and time. Okay, and it's not taking into account outdoor air temperature. So if any sensor in this unit, well, I should say any thermistor in this unit, if it fails, the unit will try to maintain operation, but it'll do it with a reduced capacity. Coil temperature sensor. This is nothing new. You guys have seen this one before. It's on the Infinity and Evolution products. It's checking the coil temperature, right? It compares outdoor air and coil temperature. Thermistor out of range error. You may have seen that one. What that means is there's some relationship issue between the outdoor air and coil temperatures. If I'm condensing outside, I have to be condensing at a temperature higher than the outdoor air because I need heat to flow out of the coil and into the air surrounding it. If there's a temperature difference that doesn't make sense, you're going to get a thermistor out of range error. Okay. If the sensor fails, then it's going to try to continue operation, but at a reduced capacity. Here's another type of sensor. This is the suction pressure transducer. Takes place of the low pressure switch. There is no low pressure switch. It uses the transducer. This helps with loss of charge management, overall compressor envelope management, okay, keeping the compressor in what I call the happy place, oil circulation and lubrication management, and EXV control. So this transducer does a lot. It provides a lot of input. Braze plate heat exchangers on the 5-ton units only, the little subcooler, okay, basically there to increase capacity, okay, part of the vapor injection circuit. So here's just kind of showing you the in and outs of the refrigerant, okay, and so it's really pretty easy to understand. EMI filter board. This is electromagnetic interference filter board. On the previous Greenspeed model, this was an accessory that you had to order if you had some issues. This is standard in the unit. The EMI filter board can fail. If it fails, your unit will not operate. Why would it fail? Well, something took it out. It could have been a surge of some sort, or maybe the unit's located next to some kind of radio tower or transmitting, something like that, transmission tower or something like that. That could cause some issues, but it is a replaceable component. Okay, but it's there for protection. Your motor control and drive, the VFD, the inverter. Okay, they look a little bit different depending on the size. 2 and 3 is the same. The 4-ton is different. The 5-ton is different. But your inverter, or VFD, if you will, same thing. It's converting your AC input voltage into a variable frequency AC output using pulse width modulation. Okay, pulse width modulation is like a switch coming on and off very rapidly. I mean, extremely fast. Okay, and so that's pulse width modulation. It runs the compressor and the fan motor. Okay, and it adjusts the voltage and keeps the compressor within a safe operating envelope. Okay. Bluetooth module. This is strictly here for us, guys. Without the Service Tech app, you can't connect to it. If the board fails, unit still operates. but this is simply for the technicians. Hey, I want to connect to this unit. I want to get some information and at my fingertips, and that's what this is for. Sound blankets. There are 2 sound blankets here. When these units first came out, we got our hands on them and pulled these things off. And these things are pretty heavy. You know, don't take the blankets off unless you absolutely have to. You know, if you need to get to the compressor terminals, yeah, I mean, yeah, I understand that. Take the blanket off, but you know, if you don't need to, don't do it because they're cumbersome, they're heavy, and there's 2 of them on there. Okay, brushless permanent magnet motor, right? These are in the compressors. The motor inductance reacts to the drive current, and sinusoidal current is induced through the motor windings. Okay, what's that mean? The motor's running really fast. Okay, it's a rotating magnetic field with a permanent magnet. Okay, so it eliminates the slip issue. All right, and so it can synchronize the frequency, makes it more efficient. Okay. Compressor input terminals, you know, your resistance values are right here. Now, these are pretty specific, you know, 0.453. Everybody's meter is a little bit different. You know, I don't even think my meter reads to, you know, this digit here. I think it only displays a couple digits. So, you know, hey, if you got 0.5 on all the windings, okay, the compressor is okay. Even if I read 0.7 on all the windings, the compressor's okay. All right. Now these values are here. That's at 68 degrees. You know, it may be the middle of the summer when you're ohming this thing out and it's not 68. So you might have a little bit of variance there. You're checking your meter frequently, right? It's one of your safety tools. So, you know, you should ohm them out, you know, put your meter leads together, ohm them out and see, you know, do you need new leads? If you put your meter leads together and you read 10 ohms, hey, it's been time for a new set of meter leads, right? So check that stuff periodically. Crankcase heater. A firm believer, a crankcase heater should be on every compressor, no matter what the application. This comes with an outdoor crankcase heater, okay? And it comes on anytime the outdoor unit is powered. All right, so it's a good safety feature for the compressor. The fan motor, operated by the VFD. It will keep the fan motor on in certain situations, over pressure, over temperature event, to try and expel any residual heat. So the fan motor, you know, will vary its speed based on, you know, the capacity demand. Here's a look, and I'll zoom in on it a little bit at the VFD. There are some terminals here that you can measure the DC voltage that's coming out of the drive to the motor. Okay, now the fan is actually 4 wires. Okay, there's 2 plugs, and there is actually a little fuse, a replaceable fuse for that fan motor. Okay, so a little bit different than what we're kind of used to. There's a compressor plug, UV and W, on the 4 and 5 ton units. On the 2 and 3 ton units, and I'll zoom back in on it. There's terminals there. You know, you'll put the terminals there, and so that it goes on properly. You can, you know, switch the leads around, would be a problem, but the VFD can identify that. With the Molex plug, you can't turn it the wrong way. It's polarized. 5-minute delay at the start of each cooling or heating cycle. That's pretty standard. You know, active envelope management, the PCM is trying to take the input it gets from the different sensors and keep that compressor in what I call the happy place. That is active envelope management. When the compressor starts to get outside of that happy place, then we start to have failures. Okay, and so that's the job of the PCM, is to take all the information and keep that compressor in the happy place. It's going to maintain safe, reliable operation. It's always proactively trying to protect itself, but also simultaneously trying to maintain operation. Like I said, if some certain sensors fail, it will maintain operation, but at a reduced capacity. What's nice on the PCM is it has a display, no more counting the flashes. Okay, now you can still count flashes. There are LEDs to count, and they do have a meaning, but it's much easier to just read the LED matrix. Okay. A solid red LED indicates that there's power to the inverter. A green LED indicates there's communication. Okay, green LED on the PCM indicates there's communication. Steady flashing on the PCM is normal. Okay. VFD communication, you can see that as well. So there's a couple different green lights. So you're communicating with the VFD when that's flashing. That's good. Green is good. Red is bad for the most part. Some of the red LEDs mean power, but for the most part, green is good and red is bad. You got your amber LED, like always, you can count the flashes, but again, much easier to just read the PCM LED matrix. Here you can see a fault code 3913, okay, and then you look up in the service manual, hey, what's 3913, instead of counting the flashes. Bluetooth module on the bottom of the unit, there's like a sight glass where you can look through the unit. You know, a lot of guys just kind of stick their shoe there. They can see the light shines off their shoe. If it's red, they're not connected. When it turns green, they're connected. Okay, so pretty easy, pretty straightforward. There is a utility terminal. Okay, so if they got the FPL box or any of the utility providers that have that, you know, they can shut the unit down or reduce capacity when the switch is engaged. You have to turn that feature on at the user interface. It comes defaulted off. Defrost. I know we're coming up on our cooling season, but you know, I love heat pumps, and defrost is a crucial element of heat pumps. But the defrost intervals are selected by the wall control. There is no dip switches. Okay, it's defaulted to auto, which tries to make the best use of defrost. Defrost is an inefficiency, okay, but it's required. It's kind of like superheat. Superheat on paper is an inefficiency, but it's required because you can't compress liquid refrigerant. Okay. So defrost is an inefficiency because we're taking some of the heat that we just put into the space and we're using it to de-ice the coil or defrost the coil, probably a better word. Here you can see the different time delays. Okay, but auto will adjust automatically and try to make the best use of defrost. Now you can set the time intervals, but it kind of goes back to using our efficient unit inefficiently. Auto is really the best setting there. Continuing with defrost, if the coil temperature is less than 32 degrees, the control board begins to accumulate compressor runtime. When the accumulated runtime approaches the interval, the defrost is initiated. Okay, and at the initial power up, it's going to wait 30 minutes and do a timed interval, and then after that, it'll begin to look at the coil temperature and the outdoor air temperature and runtime and defrost automatically and try to make the best use of it. Defrost is only allowed to occur when the coil temperature is less than 35 degrees. And defrost is terminated when the coil temperature reaches a predetermined temperature. That changes based on the unit and the outdoor air temperature. So there's a few different factors there. Compressor speed during defrost also varies based on the unit and model. Model plug. Model plug is there still. These have been around for some time. Okay, so you guys should be familiar with these charts. These charts are also on the schematic. Okay, so I talk to guys all the time. They call up and say, "Hey, what's the resistance value on the model plug?" And we figure it out. And I say, "Look at the schematic; it's right there too." Just want to let you know. Okay, but it's here as well. Again, a lot of guys flip to this as a quick reference, and hey, I got a 3-ton heat pump. What's the model plug part number? Here's the resistance values. Okay, am I good or not? Right. So pretty easy, pretty straightforward to troubleshoot. High pressure switch. In theory, your high pressure switch should never open because you have a discharge pressure transducer. Now, the high pressure switch will open at 670 psi, plus or minus a few, and it closes at 470, plus or minus a little bit more. If your high pressure switch is opening, you've probably got non-condensables in the system. You could see high pressure switch faults if you had a loose connection. Okay, when that happens, the VFD is de-energized. So that will bring up a communication error with the VFD. Okay, so it's important, if you get a communication error, we got to eliminate, hey, did the switch malfunction? Is there a loose connection with the switch? Something like that, check your high pressure switch. After the discharge pressure drops below 425, then it should come back on. Again, the discharge pressure transducer will protect the system and shut it down before the high pressure switch opens, in theory. So keep that in mind. The only calls I've had to take on a high pressure switch was one with a loose connection. High pressure switch trips do not escalate to malfunction. Okay. Again, loose connections, breaks in the wire could simulate a high pressure switch trip. Rapid increase of discharge pressure, usually a result of non-condensables. Yeah, the transducer is there to protect it, and it should shut the system down before your high pressure switch ever gets there, right? And so when it does that, the system's going to go into a protection mode. It'll reduce capacity, 25% less capacity every time the fault occurs. And then it'll bring back that capacity after you have so many hours of runtime without a fault. Okay, so it really tries to protect the compressor, like I said, at all costs. The suction pressure transducer is there in place of our low pressure switch. Okay, we don't have a low pressure switch. We're using the suction pressure transducer. It's going to, change speed of the compressor. If it senses a low pressure, lowering the speed of the compressor should raise the suction pressure, and that's what it's trying to do there. In heating, it opens the EXV to maintain suction pressure, so it's working there as well. And then there are some model dependent faults that occur, but generally pressure less than 15 to 30 psi will result in an immediate shutdown. Low pressure shutdown, displays a fault code on the LED matrix. You'll also get it on the wall control. You could also view it on your Bluetooth module. If you still have a demand for operation after the delay, the unit will resume operation. It's going to try to maintain operation at all costs. But if you continue to have trips 4 times in a couple hours there, then it's going to lock out operation. You're going to go into a lockout for 4 hours and it will not come back on. So in that event, check your charge. It's still air conditioning, guys. It's still a compressor. It's still coils. There's just a lot of protections on here because, who wants to change a compressor every day, right? Not me. So, we try to keep the compressor in a happy place, and so it has safe, reliable operation for a long time. All right. So, low pressure is still caused by, lack of refrigerant. Okay. So, don't get overwhelmed at all the bells and whistles on this thing. And still at the end of the day, we're still doing air conditioning, and that's what it is.